Hi everyone, welcome back to the Strivers A to Z sheet, and today we'll be solving this question, that is print subarray with maximum subarray sum, extended version of above problem. So here we have done the maximum subarray sum, right? But in this question we will be solving a similar type of question, but it says print subarray with maximum subarray sum. So basically in this question it given that given an array r with we are given an array with num with name array with indexes running from 0 to n minus 1, okay, and select any two indexes I and j such that I greater than is equals to j minus 1. From subarray array I dot dot j, find the two smallest numbers and add them. You will get score for that subarray. Your task is to return maximum score possible in the given array, right? So we are given an array here 4 3 1 5 6 and the output is 11, right? So 5 and 6 is the small is the number that gives the maximum scores. This line doesn't actually really mean anything. This line is just to confuse you, okay? Just we have to find the return the maximum score. So 5, just find the maximum number in the given array. So 5 plus 6, see, before you can even see that 4 plus 3 and all, right? So amongst everything, maximum sub above choices 5 plus 6 gives us 11, right? And here again you can see that 5 plus 4 are the one it should be contiguous, right, which gives 9, right? So you have to just check two subarrays here, okay? In the previous question it was continuously any number of subarray, but here the question seems to be asking only the solution for two contiguous subarrays, okay? So here we have a long and we have taken this answer is equals to 0 here, right? We have initialized because every function is long here, because you can see the constant is 10 to the power 18. Of course you have to take long answer, and I have run a for loop here and I have used a long sum is equals to, see, it's already says 0 to n minus, so 0 to n minus 1, long sum is equals to, I'll be keep on adding the contiguous two arrays, that is array, this is array I and next array will be of course I plus 1. If it's 0 then this is 1, so 0 plus 1 is gives 0. If it's 1 and this is 2, right, this is the indexing and 1 plus 1 gives 2, so therefore I've written array I plus 1, okay? And answer is equals to maximum of answer sum. Sometimes, see, first of all this will be added and then again first 4 will be added and then 3 1 will be added and then 1 5 will be added, and at the last we will be adding 5 and 6 and then 6 and 4, but 5 and 6 are maximum, so this maximum will be keeping updating and maximum will keep the updated number 11. As soon as it gets 11 wouldn't be removed again. So that's why this is the answer for this question, and we have the time complexity as of course big O of n, right? And the space complexity is definitely big of 1, right? Because we did not use any other data structure like anything to store the array numbers here, right? And time complexity was of course big of n, right? Because we have used a single for loop here. And now let's look to the second question. So we will be solving this question basically in this video. So we have done with this question, and now let's move to this stock buy and sell. This is this solution, this one which we have done today. Now this actually have a single, in brute force also this is basically the same solution for brute force, optimal, best, everything have a single solution here according to my knowledge. And let's now look at this question, that is stock buy and sell. So we are given this question here, right? So we are given an array prices, we are given an array, the name of the array is prices, where prices I is the price of the given stock on that ith day. So we are given the array of prices, okay? So this are the prices given, okay? And on this 7 is on the 0th index, right? Let me be more clear. See, 7 is at 0 and then you have 1 and then you have 2 then 3, 4, 5, right? So 7 is on 7th, on the day of 0th day. 7th was the price of the stock on the 0th day, and on the day of 1 the price of the stock was 1, and on the day of 5 the stock price was, on the day of 2 price of the stock was 5, on the day of 3 price of the stock was 3, and 4 and 5 similarly 6 and 4. So you want to maximize your profit, right? Every time in your life you want to maximize your profit. So choose a single day and to buy one stock. One day you'll be buying a stock, and then choose a different day in future to sell that stock. So future means in the forward, right? Similarly, if you want to choose you have to buy the stock first, right? Then only you can sell it. So let's buy the stock. So to maximize your profit, you will buy the stock on that day only, which you are having a less number of price. So here in this array you can see we have one is the smallest, right? So let's buy the stock on day 1, which price is equals to 1, right? You can say this as day 2 also, no worries, you can say anything. If the indexing is starting from 1, then this will be day 2. If the indexing is starting from 0 today, then it will be day 1, right? So on the day of 2 or 1, according to the indexing, I'll say day of 2 because in late code they have took the indexing from 1. So on the day of 2 the price is 1, so I bought the stock that day, and now I want to maximize it. I want to maximize my profit. So which day shall I sell it? See here in the future you will say that 7 is the day, that day we should sell it. But no, we cannot go back because this question says you have to sell it in the future. You cannot go back to the past. In real life, can we go back to the past? No, we cannot. For that we need a time machine which is still under maybe construction, whatever. So you can only go to the future. So in the future you have to check which is the largest. 6 is the largest, right? So just 6 minus 1, because you have waste 1 rupees, right? So 6 minus, you have bought it with 1 rupee, so 6 minus 1 is the 5 is the answer. And see here, if you buy it on day 1, because this is the smallest, they have asked you have to maximize your profit. If you do not have a profit, then just return 0. Okay, so here you can see, say if you have the smallest, at first our main target is to find the profit because you have to buy it. So find the smallest. So 1 is the smallest here, right? But before 1 there is nothing and we cannot go back to our past. So this of course doesn't have any solution, though it will be, this example will return 0 because the maximum profit is 0. You cannot buy or sell it. Now look at the solution for this question. Okay, this is basically the brute force that I have done. This is very easy. Okay, this will give you a this will give you a TLA, of course. So I have taken a max profit. This will be my final answer, returning that. And then I have used a for loop to run the outer loop, and then a J array. Another loop, that is J. And now J will be, if I is here, J will be here, right? And if J, I have to check if J is greater, right? Then I, then just J minus I, that will be the maximum profit, right here. So I've just used, if prices, if J, see you have to, after taking the smallest one, you have to find the bigger one. So J will be here, I'll be here. So they will just, okay, so J is bigger. So now just 6 minus 1 is 5, right? So that is our maximum profit. And this solution will always give you a TLE, okay? Because the constant is, see here, the constant is very critical. So this time complexity will be, giving a TLE. I already got this TLE for this. See, okay, now let's just run it and show you once that I have got a TLE. Okay, see, it is taking a lot of time already. Yeah, I got a TLE, right? So now let's look at this solution. Another approach that actually came in my mind was very simple. See, just find the smallest number, right? And after finding the smallest number, find the largest number and then minus it up in the future, in the number in the big forward direction, not in the backward. So I have taken a maxi and a minimum. So I'm traversing it as simple as that. Whenever you take mini, let it be int max. Okay. I have told in the previous video, whenever you are taking maxi, just initialize int mini because you have to compare it. Okay, so mini int mean is the smallest number. Okay, variable. So if you take maxi with int max, so it won't maxi will be itself returning. So you have to take the int max, int mean with int maxi. Similarly, I have taken int max with int mini here because I have to find the minimum number, and that can be only compared with int max because minimum number will be always less than int max. Therefore, I have taken int max, or you can take first array. Now prices, index 1, prices 0, that is the index 1. So I'm traversing through this array, and then mini is equals to mini price is I because I am finding the smallest number. So with this mini variable, I am finding the minimum number here, right? And with the maximum number, I am just subtracting it with the, see, when I've got a mini here, and then I'm subtracting it with the prices that I have already got, and this is already my mini. Using this mini function, I am finding the mini number as well as another bigger price. So when I got this bigger price, that is 6 minus 1, because mini was already stored here. So this will be the final answer, return maxi. As simple as that. And time complexity for this will be, see, very simple. I just used a mini variable and a maxi variable too. Mini is for just finding the mini, and maxi is finding the maximum variable, and after finding it, it just minus, because you have to buying it, and then therefore I have to different subtract it. After then only we'll get the profit, right? Time complexity will be big O of, oh shit, big O of n, right? And the space complexity will be big O of 1, right? Because one single loop, and we did not use any other thing to store the space here. So I hope you understood this both of the question, and yeah, keep on solving, keep on grinding. Bye.